Okay, a couple years ago, talked about naturalistic driving studies at the Virginia Tech Transportation Institute, VTTI. You can think of a continuum of our research as the amount of automation in the system. Naturalistic driving study, we watch the human species in situ, as it were, instrument your vehicle. And we finished up a large study, and we do this a lot with other studies as well, of 2,000 vehicles for 2 years. We've got 18 trillion records in our DB2 cluster and things like that of sensor data. At the other extreme, other things you've heard a lot about in the news, of course, more automated vehicles, sometimes called autonomous. We're going to go in the middle this time with connected vehicles, vehicle to vehicle and vehicle to infrastructure. To make sure that we have plenty of buzzwords up there, granted a bingo card should be odd celled, but I'm odd enough, so I went with an even square instead. So we've built a test bed, as it were, for connected and automated vehicles similarly. The Smart Road is a 2-mile loop built to interstate grade. It's actually owned by the Virginia Department of Transportation, and we operate the research there, where we do our initial deployments. We have about a dozen pieces of roadside equipment of this radio communication, the vehicle to infrastructure, and then deploy that in production to currently 44 pieces of roadside equipment to the busiest corridor in America, which, as much as we might like to believe that is in Silicon Valley or Chicago, is actually the I-495, I-66, US 29 corridor near McLean, Virginia. And right now, the fleet of vehicles does not have a rich amount of the dedicated short-range communication 5.9 gigahertz radios, so we also augment this with levels of connectivity that are more cellular-based. Some things about the development of this infrastructure, though, it changes the model quite a bit in the large naturalistic driving study. We're talking more about volume. There was some velocity sort of discussion about how do you get data in, make sure all 2,000 vehicles get their data in every day. But in the case of connected vehicles, where we want to try to understand the behavior of the vehicles and the messages that are going on all the time, each instrumented vehicle going down the road, or rather connected vehicle going down the road, has a 10 hertz, here I am message is going on. And we try to gather that for use in actual real time in the tens of milliseconds. It's probably close enough that we can all believe that's real time-ish. And so to build that out, we have this architecture that intends to be able to be hyper-scalable, built on containers currently with some message queue stuff and things of that nature. We also harvest from those queues to go into DB2 as well for potentially some longitudinal data analysis. There's a picture with clouds on it. And the dedicated short-range communication, again, is that 5.9 gigahertz, which has these well-identified message types, which include basic safety messages, traveler information messages, similar types of messages. There's a very good data standard around that. There's not data standards for what comes off of the ODB port in your vehicle, by the way. There's a communication standard in terms of it being component area network, but what the vehicle manufacturer puts on there is very much not standardized. But that is the case for DSRC communication. So we can put some plots on the map, and there you go, driving down the road. There's been a lot of look into, you can't identify a vehicle as it crosses through there, but in short time scales you can, so that vehicles can talk to each other. On the vehicle-to-vehicle side, you might have the person 2 cars in front of you slam on the brakes, and instead of waiting for brake lights, and maybe a half a second later you might be able to react to that, your vehicle could potentially detect that from this radio communication that happens all the time. And this is sort of another way of using that same here I am message, just to say, here's some places vehicles have been in the network recently. Similarly, we can push information out. We have a mobile app as well that can communicate via Wi-Fi or cellular, again, because DSRC itself is not very richly embedded in the fleet and can give out work zone details and things of that nature. Internet of Things, I should mention that too. I think that's on the card. Anybody win yet? So another sort of thing that might be out there is these bipedal things that sometimes we find along roadways. And we want to, if we can have them instrumented, they similarly could communicate their location as the vehicle to, well, it is a vehicle, I suppose. So we have a vehicle-to-vehicle or vehicle-to-infrastructure communication going on at that level as well. So some things that we've learned along, again, this fits into the Internet of Things framework as well. And some things about the things is scalability of the address space, which we tend to forget about. That's an important part of this. There's a local versus global. That vehicle to vehicle is very, very local. In fact, the DSRC itself, you're talking to just roadside equipment that you drive by, and how do we get that information out there? So, any winners?